Hi students, welcome to Dr. B.R. Ambedkar Open University, and today I will discuss about the risk identification, application of remote sensing, GIS and GPS in risk assessment, which is of disaster management. Now you know that hazard, exposure, vulnerability, disaster and risk are the foundation of disaster risk reduction and resilience planning. And you know the definition of a hazard. Hazard refers to a potential threat that may cause harm to people, property and environment. It only represents the possibility of harm. Now, exposure refers to the presence of people, infrastructure, property or economic activities in areas that are prone to hazards. So, that we are calling as exposure. It also implies a lack of protection against these hazards. So, these we are calling as exposure. Now, coming to vulnerability, describe the degree to which people, property and systems are likely to be affected. When a hazard occurs, it reflects how susceptible a community is to the impact of a hazard. Then here the important thing is risk. What is risk? Risk is a possibility of loss or damage occurring due to a hazard at a specific time and place. This is very important. And risk arises only when a hazard interacts with vulnerable and exposed elements. In disaster studies, risk is commonly expressed as this is hazard multiplied by exposure multiplied by vulnerability. Now that we are calling as a risk, and you can look at this figure. In this, the risk is equal a multiplied of hazard, exposure and vulnerability. This means that if there is a high hazard, high vulnerability, there will be high risk, and if there is a high hazard, low vulnerability and there will be a lower risk. Now already you know what is a disaster. A disaster is the actual occurrence of a hazard that results in severe loss of life, property, infrastructure, environment and causes disruption to normal services and economic activities. Then if you look at the understanding the disaster risk does not stop with hazard, exposure or vulnerability alone, but an equal important component is the capacity of community to protect itself from disasters. So, community capacity includes first they have to preparedness and awareness, early warning systems, institutional support, availability of resources and infrastructure. Communities with higher capacity experience lower disaster impacts even when the hazards occur. So, that is the importance of communities. So, the community should have the capacity of preparedness and early warning systems, all institutional support and availability of resources. Then now the concept of resilience. Resilience refers to the ability of community and its socio-economic systems to, so if the community withstand the impact of disasters or recover quickly after a disaster, adopt and improve well-being over time, that we are calling as resilience. Resilience emphasizes long strength rather than the short response. It is a key concept in modern disaster management and sustainable development. Risk assessment is a systematic process used to determine the nature and extent of risk. Means by risk assessment you can identify the nature and extent of risk by analyzing the hazards and vulnerability. It helps in understanding how different hazards can potentially affect people, property, services, livelihood and the environment. Now, through risk assessment, we can identify the potential harm and exposed elements, and we can estimate the magnitude and likelihood of losses. And third one is to understand the causes and consequences of such losses. The outcome of risk assessment support the formulation or revision of disaster risk reduction strategies, making it critical input for planning and policy making. So, this is the main objective of risk assessment. Risk assessment, through this you can formulate or you can revise the disaster risk reduction strategies. So, this is very important or critical for the planning and policy making. Then the another thing is risk identification in disaster risk assessment. So, identification is a critical step in a disaster risk assessment. It requires a clear understanding of the type of hazard, what type of hazard it is. Is it a flood or earthquake, cyclone or drought, etc. Or time, seasonal occurrence or frequency and duration of that particular hazard. And the another thing is the strength or magnitude, or either it is intensity, what type of intensity it is, what type of severity it is. So, understanding these characteristics allow planners to estimate potential impacts and plan appropriate mitigation strategies. Risk assessment and mitigation. Risk assessment involves, already you have identified the type of hazard, and you can also make different aspects and measure that can reduce the losses and protect livelihoods. These measures are known as mitigation measures, and it may be a structural measures or non-structural measures. Structural measures are embankments, cyclone shelters, earthquake resistant buildings, and non-structural mitigation measures are land use planning, policies, awareness programs, and by this mitigation reduce vulnerability and enhances the resilience. Now, next we will see about what is the components of risk assessment. Risk assessment involves several interconnected components. First, that is risk analysis, risk evaluation and risk management. So, in risk analysis, this is a stage where we can understand how much risk exists and where it exists. This is about the risk analysis. Means here in risk analysis involve the objective quantification of risk components such as the characteristics of hazard, exposure of population and assets, and also the vulnerability of elements at risk. So, if in this risk analysis these type of objective quantification will be done. And then risk evaluation. Risk evaluation assess the expected losses based on the probability of hazard occurrence or severity of damage caused by hazards, or it compares estimated risks against the acceptable risk levels to guide the decision making. And the final one, the component of risk assessment is risk management. Risk management focuses on analyzing, implementing and reviewing measures to reduce the risk. So, these are the very important things to minimize the or reduce the risk. Then look at the figure here. Now, look at the figure, risk analysis. In the risk analysis, risk evaluation and risk management. So, these are interconnected. Now, in risk analysis, what could happen and what could it happen, then where could it happen, and what is the possible, what is called as look at this figure. This figure shows about the risk assessment components. One is risk analysis, risk evaluation and risk management. So, all these are interconnected, and here in risk analysis what could happen and where could it happen and what is the possible severity. This type of questions arise in risk analysis, and in the risk evaluation what is allowed to happen and what must not happen and what is affected. This comes under in risk evaluation. and in the risk management what is to be done and where can it be done and what are the choices. These type of components are very important in risk assessment. And then the risk management strategies. So why risk management strategies? It is very important strategies. So there are different approaches are adopted depending on the level of risk. So if the potential losses are low and manageable, that we are calling as risk acceptance. And if there is a restricting development or relocating settlements from highly hazard prone areas, that we are calling as risk avoidance. And another one is, if you want to reducing the vulnerability through structural or non-structural measures, such as that we are calling as risk reduction. Early warning systems, flood diversion channels and levees, and slope stabilization and land use regulations. And the another last one is risk transfer. Risk transfer is nothing but if the sharing losses through insurance and reinsurance can be taken. By this way, we can transfer the risk. Then another concept that is called as the multi-hazard risk assessment. What is a multi-hazard risk assessment? It deals situations where more than one hazard occurs simultaneously or sequentially, such as floods, cyclones, earthquakes and droughts. If this situation occurs, that we are calling as multi-hazard risk assessment. India is particularly vulnerable to multi-hazards due to its diverse physiography, long coastline and seismic zones and monsoon dependent climate. And multi-hazard assessment provide a strong basis for long-term planning and management of floods and droughts. Now, here in this chapter, the important aspect is that the advanced technology like remote sensing, GIS and GPS are used in assessing the risk, and this spatial technology plays a key role in disaster risk assessment. And the satellite based remote sensing provides multi-resolution. What is multi-resolution? Multi-resolution is nothing but you can have meter to sub-meter resolution satellite imageries are available. Based on that, you can assess the hazards. Then spectral, multispectral. Multispectral here means that different bands are used to assess the what is called as hazards in remote sensing. And spatio-temporal data for hazard mapping. So spatial temporal means now for example, if disaster occurs, so we will take the different period of time. So what is the damage caused because of that? All these can be assessed through this remote sensing, GIS and GPS. So now integration, GIS integrates, displays and analyzes the spatial data for risk modeling. So for risk modeling or make models, the GIS is used, and GPS supplies accurate ground level location and measurement details. Now satellite based remote sensing and GIS techniques are widely used for scientific risk assessment. These technologies allow mapping of hazard zones. So number of hazard zone maps are created by using this remote sensing, GIS and GPS, and analysis of exposure and vulnerability. And this analysis of exposure and vulnerability by using this spatial technology and integration of multiple spatial data sets. So the disaster mainly depend upon not only a single factor but the different factors. So the integration of multiple spatial data sets also we can analyze and we can make the hazard maps. By overlaying hazard maps, land use maps, population maps, GIS helps in identifying high risk and vulnerable areas. Then coming to the what is the importance of multi-hazard risk maps. So the important is that it help identify the vulnerable regions and communities, so that we can create a map by showing the what are the vulnerable regions and communities which is affected by a hazard, and it can support the prevention and mitigation planning. So once you will do multi hazard risk maps, so you can minimize the risks and it will be useful for mitigation planning, and it will assist planners, disaster managers and policy makers in informed decision making. So ultimately these multi hazard risk maps are used for disaster managers and policy makers to make decisions. And another important concept is that without participation of communities, local knowledge, we cannot make a decision. Participatory decision making supported by local knowledge further enhances disaster planning and response, ensuring that risk management strategies are realistic and community oriented. If it is a community oriented and if it is a realistic, then the decision whatever that taken, it will be the we can minimize the risks. And then by remote sensing, GIS and GPS, we can make different applications. So we can create number of maps, like for example hazard mapping is the one. So and another thing is threat maps is the one, and the what is called as landslide analysis is the one. So these are the applications we can do by remote sensing, GIS and GPS. So first we will see about what is a hazard mapping. So it is an important application of risk assessment in preparation of hazard maps using satellite imageries. These maps can depict earthquake, landslide, flood and fire hazards. Such maps can be prepared for villages, cities, districts or entire country. So like these maps, number of maps are created for India regarding the earthquakes, landslides and floods, and GIS will enable analysis to determine hazard prone risk zones in the map, which will be useful for planners, developer and insurance companies to take preventive action in such a risk prone areas. So already you know that we can prepare a hazard prone risk zones in the map by even micro level to a macro level. And look at this figure, this is showing about this is a hazard mapping where the seismic zone map of India, which is showing different zones, and here they are given different categories, that is in what is called as zone, and here in the zones is representing one zone which is northeastern part. It is completely very high risk seismic zone, and the part of northern part of India also there will be a high risk seismic zone, and the other aspects we can see that here the high risk zone and moderate risk zone and also the low risk zone. So this complete blue part, it is of low risk zone. Like this we can prepare a maps of India at village level or at district level or at country level. So by overlaying GPS receivers, data and maps will help to access the geographic coordinate of specific hazardous location with high accuracy and timing for tracking. So using data on epicenters, faults, geology, slope and settlement, we can make the earth risk what is called as earthquake risk assessment. And then another applications that are called as threat maps of cyclones. Threat maps of cyclones generally in India, the coastal Indian affected by these cyclones. So when there is a cyclone, we have to give the warning services by the meteorological department. So threat maps of cyclones or tropical cyclone threat maps help to improve the quality of tropical storm warning services by meteorological department. Threat maps also help in real-time simulation of wind vectors. Means you can track the cyclones and identify what are the potential risk zones to communicate to people likely to get affected by the cyclones. So already when the disaster occurs, this or when the cyclone occurs, this type of maps we can prepare, and using remote sensing and GIS, the threat maps can be suitably overlapped with the population land use map to derive the risk assessment. So not only when you prepare the risk maps or threat maps, you have to incorporate the layers of population and land use maps, so that it is very we can make a different applications by using this remote sensing and GIS. These maps are very helpful for disaster managers and involved in risk assessment and disaster mitigation. And look at this figure here at the coastal part, we are district wise or the prone areas. So the red area indicates very highly prone area districts which are at the part of the coastal part of India, and the blue color is highly prone, and the green color moderately prone, and the yellow color which is of low prone areas. So you can see that this type of maps we can prepare through district wise. So by seeing that we can prepare the threat maps of cyclones. And the another important aspect is landslide analysis. So basically, where there is a mountainous area, where there is a steep slopes, where there is a deforestation occurs, the landslide takes place. So to identify these areas susceptible to or to landslides, analysis of factors such as land use is the must, agriculture and rainfall data is must, and deforestation and geology of terrain and steepness of slope trigger the occurrence of landslides. So these all parameters we have to overlay one over the another, and you have to find out the what is called as susceptibility to landslides. And also increasing population in size and density will enhance depletion of resources. So everybody knows that if there is a lot of pressure on the resources, the resources will be depleted, and increasing rate of deforestation and destabilization of slopes, this may trigger landslide activity in mountainous regions. So ultimately it will impact the landslide areas. And integration of remote sensing, GIS and GPS collected data help to analyze, visualize landslide prone risk areas. So you can see in this map, these are what are called as, this map is prepared that is called as landslide prone districts in India. So by seeing this map, you can say that the northern part and northeastern part of India is what is called as landslide prone districts with not only the landslide but also earthquake. And there are some districts with only landslide, but these are the places with landslide and earthquake, and these are the other part of the states. So in this way, by using the geospatial technology, we can make the maps landslide analysis. And another important application that is called as insurance underwriters. What is a insurance underwriter? So insurance underwriters access geolocation data on demographics or property values or crime rates or location of fire hydrants, police, fire stations, etc., delivered through GIS. So because of that, what is the using of GIS? Underwriters take real-time decisions to underwrite a property for fire or natural hazards to decide premium for the insurance cover. GIS tool help the insurer or income levels, buying and policy trends. So here is the one of the figure which is satellite imagery, which is showing about what is called as potential new policies. So in this way, the insurance policy makers, they will use the satellite imageries. And then the another one, in the recent years, we are using the drones in disaster risk assessment. And drones, commonly known as unmanned aerial vehicles or remotely plotted vehicles, are increasingly being utilized in disaster risk assessment and management. So these are some of the following ways in which the drones are used. So to assess the extent of damage to road, rail infrastructure, building and other facilities, fast in search, rescue and emergency operations, and quick to fly in inaccessible disaster areas, and application of high resolution sensor and videos in quick disaster risk assessment surveys. And it gives real time situational awareness and distribution of medical kits and posts. So we have seen number of times when the disaster occurs, the drones are used to transport medical kits and post different distribution, and pre-disaster and post-disaster planning also we can use the drones. And here you can observe that figure here, the drone, how it is at the time of disaster, how the drone can capture the spatial and non-spatial data, and these provide more accurate data. At lowest height, it can fly to 100 meter, and particularly along the coastal area that is difficult to access, and one of the best tools to analyze shoreline changes as well as other coastal problems. Then remote sensing and GIS help to create a geographical, spatial and non-spatial digital database, which is essential prerequisite for preparing maps for different hazards for a disaster management plan up to various administrative levels. So already, so village level, or we can say up to national level, we can create the disaster management plans. Coupled with GPS will enhance the accuracy of risk identification and in developing evacuation route plans for safe exit of emergency in the time of emergency response. Now I will give one example. Maharashtra state has one such plan with a database up to a Tehsil level. So the plan integrate with the essential service agencies like hospitals, traffic police, fire stations, railway radio stations, etc. Finally, the plan is networked to communication modes to link the control room at Mantralaya in Mumbai for dissemination of disaster information on response and relief to public. So in this way we can create the what is called as disaster management plans. And then another one, in this lesson we will cover about risk assessment under UNDP. Risk assessment is an important component in disaster risk reduction program of UNDP. Under risk assessment, it provides technical assistance to establish institutional arrangements of regulations and strategies at the national level, and it supports planning and assessment of hazard monitoring and mapping capacities, compile and interpret historic disaster information useful in risk management activities, and it helps local government on risk assessment for areas of resettlement and recovery after disaster. Besides methodologies and tool to carry multi-hazard risk assessment in cities, and it build national disaster observatories, that is NDOs, which enable to collect, compile and interpret historic disaster information useful in risk management activities. Now we can conclude this remote sensing GIS, application of remote sensing GIS and GPS. The main components of disaster are risk, hazard, vulnerability and analysis. These are the most important to discuss. already we know what is risk, what is hazard, what is vulnerability, and the risk analysis. So, remote sensing, GIS and GPS risk assessment and multi-hazard identification studies, the role of remote sensing and GIS, GPS in risk assessment and multi-hazard identification studies, and also we have seen the hazard vulnerability data with a spatial and non-spatial save which the GIS database can generate. And finally, to evaluate the risk assessment, access of GIS data for potential damages and risks. And finally, to assess the potential damage caused by natural hazards, remote sensing, GIS and GPS provide reliable and accurate data to disaster managers, insurers and by communities to able to take preventive actions during pre-disaster planning and later in search and rescue during post-disaster operations. Thus, integration of these technology play a crucial role in carrying risk assessment as a mandate of disaster risk reduction activity of UNDP. Thank you very much.